Example problem 1, I have 3 isotopes of uranium, so to calculate average atomic mass I need to know the isotope's mass and its percent abundance. So the first isotope is uranium-235. I'm going to do the work and then bounce back and forth between that and the calculator. So uranium-235 is the mass, so I'll plug in the mass of that isotope. Its abundance is 0.71%. I have to move that and make that a decimal. I know it's a decimal, but it has to be made into a decimal. So 0.0071. The second isotope is uranium-238, and it's 99.28% abundant. So again, the mass of this heavier isotope of uranium times its percent abundance in decimal form, so 0.9928. The third isotope, the lightest isotope, does not give me the percent, so I have to know the difference between how much in the percent I have already from what's remaining. So that will look like the following. If I know that one of the isotopes is 0.7.1% abundant plus the other one that is 99.28% abundant, I know that those two isotopes alone count for 99.99% of the mass. I'm going to subtract from 100, even though that's pretty easy to deal with. I know it's going to be negative, but we're going to ignore that. The last remaining isotope is 0.01% abundant, so very, very little of it. So I'm going to plug that 0.01 into my problem. I know the mass is 234. Move it into a decimal, 0.0001. And now I am solving for x. I'll do that in the calculator now. So uranium-235, and it's 0.71%, but I'm moving that into a decimal, so 0.0071, plus the other isotope of uranium-238 times its percent abundance of 99.28, plus the third and final one, the mass of 234, and its times its percent abundance. The average atomic mass of uranium, I'm going to round to 3 decimal places, 237.978. Second question, I'm going to show the work. Silver has 2 isotopes. I have silver 107, and it gives me the exact mass. I'm going to use the exact mass in parentheses when given. Make sure you're aware of that. On most of the format so far, we've only given you the mass number of that isotope, but when mass exacts are given, please use that. So I know the mass of the first isotope, (106.9051). I know the abundance of that isotope, and that's 51.83%. I want to know what the exact mass of the other isotope is, so there's my x. Also, I'm not given the percent, so I need to take 100 minus the 51.83 to get the percent of the silver isotope that I'm looking for the mass. So 100 minus the 51.83 is going to give me the second isotope being 48.17% abundant. I am given the average mass. I'm not looking for average mass because I'm given average mass, and it tells me in the problem the average mass of these two isotopes together are 107.868. So I'm solving for x. So you're going to get some of these problems that you'll need to do this. So we got basic algebra that we have to cover. So the first thing I'm going to do is combine terms that I can combine and do the math that I can do. I can multiply 106.9051 times 0.5183, and the result of that is 55.4089. I can multiply 0.4817 times x to get 0.4817x. What I can do now is I'm trying to get where x is by itself, so the first thing I'm going to do is, since I'm adding 55, I'm going to subtract 55 from both sides. That cancels out. And so when I subtract 55.489 from both sides, I get this equation here. I get 52.4 591 equals 0.4817x. So now to get rid of 0.4817, I'm going to divide both sides by 0.4817. I divide 55.4591 divided by my 0.4817. My x is the exact mass of the second isotope. The exact mass is 108.904.